This video will explain how to use Fiji, which is an image editing software, to generate the Tiff stacks that are needed for microtomography import into the PuMA computational framework. To download Fiji, all you need to do is type in Fiji download into Google and click on the first result, which should be imagej.net. From there, simply select the distribution of the operating system that you have, in this case Linux 64-bit, save the file. It should download as a zip file. It's quite large. Copy this zip file into the location that you want it and extract it. Now, fortunately, Fiji does not require any kind of installation. You just have to open up the Fiji.app folder and double click on the imagej Linux. Now, once Fiji is downloaded and opened, you can import a microtomography file into here for processing. In this case, we have a 800 cubed sample of fiberform, which is the same one that comes with the distribution of PuMA, except in this case it's saved as a single three-dimensional TIFF image. To import this into Fiji, all you have to do is drag it onto the window itself, or you can use File, Open, and select it that way. If instead of a single 3D image you were trying to import a TIFF stack, you can say File, Import Image Sequence, and then select the TIFF stack desired. Once it's been loaded into Fiji, a new window will appear which will contain the stacks. Now, what you're going to need to do in order to make this usable by PuMA is change the image type to 8-bit if it is not already. This saves on memory, and it needs to be either an 8-bit or a 16-bit file in order for PuMA to be able to import it. If any filtering is needed, in this case it's not, since this image has already been filtered, but if any filtering is needed, you can use Process, Filters, and I recommend using a median 3D filter with a small radius, 2 or 3. Or if serious filtering is needed, you can go to Plugins, Process, Bilateral Filter, and apply a bilateral filter, which will do a pretty good job at filtering the image without losing the surface integrity. So to save this as an image sequence that can be used by PuMA, click on File, Save As, Image Sequence. Now this window will appear, which gives you the save parameters. You're going to want to change the name here to image_1. Now what this will do is it means that when the image is saved, it will be saved something like this, where each slice is saved as image underscore and then a number, in this case 10,000. In order for PuMA to be able to import it properly, it's recommended that you have the name of each slice be image underscore and then a number. The number can start anywhere as long as it goes up iteratively. However, the number cannot be, say, 000 and then 001, 002. It has to be 1, 2, 3, 4, or in this case, 10,000, 10,001, 10,002, etc. If this is confusing at all, it's described in more detail in the PuMA documentation. And for your reference, the example microtomography file is already in the correct format. So once that's done, say save, select the desired location, which will save it in the location that you should already have the file, and that's all there is to it. From there, it can then be imported into PuMA, which we will explain in a later video.